Okay. We are on 5.4. This is problem number 4. And we're solving a few more equations. Now, this is very similar to what we did last time and the time before. The difference is now we're going to answer in radians, okay? Otherwise, everything's exactly the same. So instead of saying 30 degrees, we're going to say pi over 6 radians, okay? There you go. You're not uniform and you're on your phone. Very bad.
That's Gabe, by the way.
Oh, Gabe, yes, I see. You are Gabe. He'd be mad if I put it in for him, wouldn't he? All right, you're Gabe.
Are we allowed to ask a question about that, please?
No, we're going to get it back tomorrow. Or whenever I see you again, you can ask that, okay? If you want to ask me privately, you can. I don't want you staying up late all night worrying about it. Okay, now, you got your colored sheets out, and we are going to do a substitution for the cosine of 2x. Now, we talked about this before. You cannot do a problem that has part of it is a 2x and part of it is a regular x. So we change the 2x, the cosine 2x, we change it using our colored sheet. Yes, ma'am. Is
it cosine squared x minus sine squared x?
Okay, that would be an option. This is one of, there's 2 formulas on your sheet where you actually can pick which version you want to use. I would go with 2 cosine squared minus 1, Izzy. Now, can you think of a reason why I might choose to go with this version of that formula instead of cosine squared minus sine squared?
Because we moved the 1 over and then put everything together.
Yeah, because if I use the one you suggested, then my problem is going to have cosines and sines in it. If I pick this version, the whole problem is cosines, and I can do what you said. So I'm going to rearrange a little bit. And I'm going to notice that this is a quadratic. And unlike that hideous one I did in the video, those of you that watched the video, wasn't that hideous? I used the quadratic formula on it. I won't do that to you on test day. On test day, you'll get one that looks like this, and it factors. Now, if you like the quadratic formula, feel free, go right ahead and use it, because it'll work. The quadratic formula will work. A is 2, B is 1, C is negative 1. But this one does factor. And when I'm factoring, my mind is always working. Positive 2x, negative x. That gives me a positive x in there. So cosine equals 1/2, or cosine equals negative 1. Now I have to figure out where that is. So we'll start right here. Where's the cosine of positive number? Forget about the 1/2 for a minute, it's positive. Where's cosine positive? Yes, ma'am.
Quadrant 1 and quadrant 4.
Yep. Now, can somebody tell me why she knows it's quadrant 1 and 4 where the cosine is positive? Abby? Cosine is x, that's right, adjacent. And that makes it positive on the right side of the grid. Now, it's 1/2, which means this is root 3, right? Which means this is 60, and so is this. But I'm in radians, so 60 is 1/3 of 180, so this is going to be pi over 3. And the answers to the problem, the first one is pi over 3. That's this And then the other one will be all the way around, which will be what? 2 pi minus pi over 3. So 6/3 minus 1/3. So 5 pi over 3. Now, I heard Reese up here, under her breath, she was saying 360 minus, and that's what I would do if it were degrees, right? But since I'm in radians, it's 2 pi. Okay? All right, what about this one? Where is the cosine -1? Now, Abby said cosine was adjacent over hypotenuse. Can adjacent and hypotenuse ever match to give me a 1? No. So I'm not going to do this. I'm going to look at this. And where on this circle is the cosine -1?
X.
Right here. Because cosine is x. What angle is that in radians? Pi. So your answers are right there. Those are the answers to the problem. Is this pretty much the same issue? You got 2x and an x. Can't do it. So what's our formula? We always change the 2x. I shouldn't say always, almost always. In this class, we're going to change the 2x. What are we going to change this into? Sine 2x. You don't get a choice. There's only one.
2 sine x cosine.
2 sine cosine, right. And that's right off your sheet. Now be careful. You are not allowed to divide because you don't know if it's 0 or not. So don't divide. What will I do instead if I can't divide? Subtract. So I'll pull that 2 sine over. And then what? Alexis?
Doesn't the 2 sine x cancel?
No. They're not like terms, so they don't cancel out, but you can do something with them because there's 2 of them in there, so we can factor them out. Yeah, we're going to factor. So basically these 2 problems have been the same. First thing we did was get rid of the 2x, put everything all together on one side, and then we factor. Now this one we factored into 2 parentheses. This one, we're just going to take out a GCF. We're going to take out 2 sine. So what does that leave us with? We take out a 2 sine. And it leaves us with cosine -1. So set them equal to 0. Always after you factor, set them equal to 0. So sine equals 0. Or cosine equals 1. Those are both on the circle. Where is the sine? Now remember what sine is. Sine is y. Where is sine 0?
The y.
On the y-axis, right here. So what are those angles in radians?
2
Pi over 2 and
3 pi.
3 pi over 2. Half a pi and 1.5 pi's. Remember, all the way around is 2 pi, right? Where is the cosine 1?
X.
The cosine is 1 right here.
Pi.
0. And that's it for that one. Okay. Alexis?
Couldn't we also say 2 pi?
You gotta watch out for these directions, Alexis. That normally when the directions written this way, 0 is included, 2 pi is not. Because it's considered redundant because they're really the same angle. So we include one and not the other one. So that's a very technical point. All right, one more section. Here we go. Do not get panicky when you see Greek letters and a whole bunch of them. If you don't like, I'm looking at problem 5 now on page 53. If you don't like alphas and betas, then call them A's and B's, or X's and Y's. So it says the given is that sine alpha is 3/5, and alpha is between pi over 2 and pi. So where is alpha? On the coordinate plane here, if alpha is between pi over 2 and pi, where is it? Quadrant 2. Isn't that right here? Isn't that 90 and 180? Over here? And the sine is 3/5. So this is a picture of alpha. I drew it where they told me to, and I labeled the sides opposite over hypotenuse 3/5. So far, so good? Now, let's do the same thing for beta. What do I know about beta? Well, its cosine is 5/13. And where is it? Where is beta? Between 3 pi over 2 and 2 pi, which puts it in quadrant 4. If you're uncomfortable with these, change them into degrees. That's 360, that's 270. So you okay with putting it in quadrant 4? And the cosine is 5/13. So this is a picture of beta. All that's given. Now, let's do our Pythagorean Theorem like we've done a zillion times and complete the triangles. So this one would be 25 minus 9 square rooted, -4. You okay with the negative? This is 169 minus 25. -12, negative again. Now, I rigged this so that it would be nice, neat numbers. Usually when we do this, we get radicals, right? That doesn't change the way we do the problem at all. All it does is make the arithmetic worse. All right, so what are we doing? We're going to find the sine of alpha plus beta. Well, look on your paper. We have a formula for that. Sine, angle plus angle. The formula says sine of the first, cosine of the second, plus sine of the second, cosine of the first. And those might be switched around on the paper, I'm not sure. Doesn't matter. Well, shoot, we can do this. What's the sine of alpha? Look up here. What's the sine of alpha?
3/5.
3/5. What's the cosine of beta? 5/13. What's the sine of beta? -12/13, yeah. And the cosine of alpha, -4/5. Just pour this stuff in, folks. Having it in. So when you multiply fractions, it's straight across. I know this one cancels, but don't, because we'll have a common denominator if we don't, so just leave it. This is going to be 15/65. Plus, these negatives are going to cancel, 48/65. So the answer to the problem is 63/65, if I have it right. that wasn't bad. Not bad at all. Tangent, alpha minus beta. Same pictures. All right, here we go. What's the formula for that?
Tan first minus tan second divided by 1 plus tan first, tan second.
Thank you very much. That's exactly right. Right off the sheet, kids. And again, if you don't like the alphas and betas, use A's and B's, using V's, whatever you want to use, doesn't matter. All right, so what's the tangent of alpha?
3 divided by negative.
So negative 3/4. What's the tangent of beta?
Negative 12 divided by 5.
So can I go ahead and make this plus 12/5? Is that okay with everybody? Because it's minus a negative. Tangent is negative 3/4. All right, well, this is a mess. Let's go ahead
Just
and,
for,
yeah,
why is it all of a sudden negative 3/4 plus 12/5? If it's,
because in the formula, it would be minus negative 12/5.
oh, because it's, okay.
All right. All right, so I've got negative 3/4 plus 12/5 over 1 plus 36/20. Are you okay with that? The negatives cancel again. Now at this point, you can do whatever you want. Now, you don't have a calculator, so whatever you do, you have to do on your own. But could you get a common denominator and add these?
Yes.
Could you get a common denominator and add these?
Yes.
And then you'd have a fraction over a fraction, and you could invert and multiply? Perfect. I don't like to do that. For me, that's more work, but everybody has his or her own style. You do whatever you're comfortable with. I'm gonna multiply everything by 20 because that's the common denominator of all 4 of my fractions. So when I multiply this by 20, I have negative 15. And when I multiply this one, I have 48. And 20 plus 36. Now, for me, that's easier, but it might not be for you. I'm not trying to confuse you. I'm giving you another option. If you want to go ahead and do the individual top and bottom, that's perfectly all right. I'm going to end up with 33 over 56. And as long as you end up with that answer, we are all good. Okay? All right, I'm going to have to erase here. I made those pictures way too big. Any question about this mess right here? All right, 2 to go. Same pictures. So now we're doing cosine 2 alpha. Now, Izzy, this time it makes absolutely no difference. It's not going to be easier one way or the other. It doesn't make a difference. Whatever you want to do. This is the one of the ones that has more than one version, though. So if I do the version you said before, which is the main one, it's like the first one, then we'll look at my alpha picture. The cosine of alpha is negative 4/5. And the sine of alpha is 3/5. And those need to be squared now because of the formula. Squaring a negative, of course, makes picks positive, so 16/25 minus 9/25. I got 7/25. You should get 7/25 no matter which formula you use. Okay? Any question about this one? All right, cosine beta over 2, so we're only going to be using this picture for this problem. Formula says plus or minus the square root of 1 plus cosine over 2. It's right on your sheet. So we'll plug in the cosine of beta. What's the cosine of beta? 5/13. So 1 plus 5/13 over 2. Now again, you can go ahead and get a common denominator here and divide by 2. That is absolutely fine. There's nothing wrong with it. I'm going to multiply everything by 13. That's what I like to do. So I end up with the square root of 13 plus 5 over 26. Which is 18/26, which is 9/13. So if I just simplify a little bit. Alexis?
Wouldn't the top simplify to the 3 out there and then just be 3 over square root of 13?
It would be.
Which then you would times by 13.
That's exactly right. Very good, Alexis. So I had 18 over 26, reduced it to 9/13. It's under a radical. So when I have the square root of a fraction, it's the square root of the top, which is just 3, over the square root of the bottom, which is a radical. So I multiplied, like Alexis said, top and bottom by root 13, and I'm there now. Are we all there? Right, here comes the tricky part. You have to decide whether you want the plus or the minus. Okay, you have to figure that out. And what happens a lot of times is kids will go back, this is the picture that we used, and they'll say, well, Mrs. Ford, where's the problem? You're finding a cosine, and you're in quadrant 4, and the cosine in quadrant 4 is positive. The problem with that logic is, what angle is in quadrant 4? Beta, right? Beta, the whole angle is in quadrant 4. I'm not finding the cosine of the whole angle, I'm finding the cosine of half of it. So the whole angle is between 270 and 360. That was given to me in the problem. Where is half of the angle then? Half of it is between 135 and 180, which is which quadrant? Where is 135 to 180? Quadrant 2. And in quadrant 2, the cosine is negative. So we actually choose the negative root in this problem. That is tricky. It gets people all the time.
So if you leave it plus or minus on the test, are you gonna cut that off?
Yes, you have to pick. You have to decide. So if you leave it plus or minus, you're gonna lose the same amount of credit as if you picked positive. Right? So you might as well pick one. Yeah. Alexis?
So if it's the 2, wait, no.
The only time we ever have to worry about that is the formulas that have the plus or minus in them. And the only 2 that you have to use are this one and the sine beta over 2. tangent beta over 2 has other versions that don't have the radical. So I always go with those other versions. But these two, you have to make a choice. And you make a choice by going back to what the original parameters were, and then just dividing them by 2. And then you know which quadrant you're in. Okay? All right, that is it. We're gonna break this chapter up a little bit. We're gonna have a full-fledged test now. We're gonna review today and another day, and then we'll have a test. And then we'll do 5.5 and 5.6, wall signs and cosines and area as kind of a test, not a full quiz. So we're going to review today and tomorrow, and we'll have a test over 5.1 to 5.4 our next class. So I don't know, do we meet tomorrow? No. Okay, so then,
It's the last
what,
month.
the next time we meet, we'll review, and the time after that, we have the test, okay? So I don't know.
Tomorrow, we meet tomorrow, it's the last class tomorrow.
So we do meet tomorrow, so then our test will be the next time we meet after that. So what I'd like for you to do is get your practice material out that I gave you. I gave you a packet of practice material. I know, I think it was Grace actually used that to help prepare for today's quiz. That was wonderful. And in the packet, there is something called Pretest, and I think that's a good place to start. So there's also something called Pretest number 2. I don't care which one we do. They both look like the test. They both look exactly like the test. That's why it's called Pretest, right? So, yeah, your review packet starts with a bunch of verifications, but the last couple pages are review sheets for the whole section. So, does everybody, the second to last page says pretest at the top. Everybody find what I'm talking about? Okay? The second to last page says pretest at the top. So let's get some erasers and let's get going. There will not be a question like number 1 on your actual test, but because we run into these complex fractions so much, sometimes it's easier to talk about simplifying them without the sines and cosines thrown in. So this is what we've been running into right here. You had one? I had one in the previous problem. Complex fractions. A big fraction with little ones in there. So your choice would be get a common denominator down here and then do the top divided by the bottom. Or what I'll do is multiply everything by xy, because doing that will clear the fractions and I don't have to worry about them anymore. So I'll have x squared y minus y squared x over, now those cancel, so I have y, and those cancel, minus x. Now do not think that you can cancel anything out, because as soon as you put minuses and pluses, or minuses or pluses in the problem, you can't cancel pieces. Like you can't cancel this y and this y. You can only cancel in a situation like this if you can take out the whole thing. And you can't. But what can you do to the top?
You can simplify it.
Well, they don't add, they're not like terms, but they do have things in common, right? So we can factor out an x and a y. And what will that leave us with? If we take out an x and a y, it will leave us with x minus y. Now, are these these two the same? No, they're opposites of each other. It's like having a 7 and a negative 7. Can you cancel a 7 and a negative 7? Yes, but it leaves you with a negative 1, right? These are opposites of each other. You see that? If I times this by a negative 1, I'll just do it. If I times this by a negative 1, doesn't it become x minus y? And it will cancel with that one, and I have negative xy as my answer. So again, I'm not going to put an algebra problem on the test, but you are going to have to be able to simplify complex fractions. You do not have to do it this way. You don't have to do it my way. I truly think that's the most efficient way of doing it, but you do not have to do it that way at all. On the test, there will be some verifications, but it'll be like your quiz. You'll be picking. You won't have to do every single one, but you'll have to choose a couple to do. So let's practice a little bit. We have cotangent squared minus cosine squared equals cosine squared, cotangent squared. You're verifying this. Yes, you will have part of the sheet on the test. Okay, we'll talk about that tomorrow. There are a few things that you, at this point of your life, should have memorized. Oh, shoot. Well, we'll start here tomorrow. You need to memorize that cotangent is cosine over sine and tangent is sine over cosine. You do not need to memorize all the UV formulas, all that. So we'll outline that completely tomorrow. Yeah, that has to be memorized. No. I'll do it.
Wait, so we'll be able to use
Most of it, yep.